I'm Matt Godbolt.
And I'm Ben Rady.
And this is Two's Complement, a programming podcast.
Hey Ben.
Hey Matt.
So we planned comprehensively as always, and today's topic is going to be signals and processes.
Yeah.
And that is the sum extent of our planning.
We said those words out loud.
And I said, yes, and hit record. And then we continued talking about it during the intro.
Uh-huh.
And we're here. So why is that top of mind for you? Is there a reason why you are worrying about this right now?
There's a reason that I'm worried about this right now, which is that I'm always worried about this because I see part of my job as a software engineer as making sure that the software that I write actually runs and does what it's supposed to do. I know that there are lots of places in the world where, as a software engineer, you're expected to write code, and then there's another group or team or organization or outsourced company that is responsible for actually taking that software and running it on computers and making sure that it continues to run on those computers and that it delivers the value that it is intended to do. And in some cases, those things are like very separated, right?
Right.
Like,
you might just make a PR to a function, you change the function, your test pass, you check it in, and then you have literally no idea how it ends up serving people's requests or whatever it is your company does. Yeah.
Right. And then on the other end of that spectrum, I think you can have situations, and I have definitely been in these myself, where it is like, no, we're building this for the very first time. There's no infrastructure team. There's you, and you are going to compile your code. You are going to SCP your code onto a server somewhere, and then you are going to run a screen and then exec that program in the screen. And now you can post in a Slack channel or some other place, hey, we've deployed to production.
And by production, you mean, yes, the only reason it didn't quit is because I'm still running it in a screen.
Yes, exactly. I did Control-A, Control-D in the screen, and now our production environment
everything's fine.
Safe. Yes,
everything's fine. What's your logging strategy? Oh, we log back in and we reattach the screen session to see what happens.
What's in the screen?
That does work, but I can understand why. Yeah, you might want something a little more.
Yes. Well, and those are the two ends of the spectrum. I think if we are going to simplify it down to a spectrum of I think that you can in your career, and I have done a lot of this as a software engineer. You can kind of hop to the left, I don't know, the side of that spectrum, and say, all right, well, okay, I obviously don't want to run it in a screen. What else could I do? And then you start learning about like systemd and things like run it and supervisor D and things like that.
Old school no hup was
right. No hup.
And then log out and you're done. Right.
Exactly. And then of course, you start moving into distributed environments, the cloud. You learn about, Kubernetes and Elastic. What does it? ECS stand for? I forget. Elastic
Container store,
something. Container service.
Something. Yeah.
Or
you've got what's the HashiCorp thing? Nomad, similar things.
Yes.
All of these things which are like orchestration setups that say, hey, you just tell me through some mechanism what you would like to have running, and I'll find a place to run them in a particular controlled way. And then you take that part of the deployment and running part is taken out of your hands. It's done by a framework, but presumably, go on.
But all of these things are accomplishing what is fundamentally the same goal, which is I have produced software and I want it to run on a computer or maybe multiple computers, maybe not multiple computers. It's like, oh, this needs to run it like
exactly one or
exactly one, right? Like there can only like something is consuming a queue and there better only be one of them at a time, or bad things are going to happen, right? Like So I think all of that is kind of encompassed in this topic of I'm trying to run a program, and how do I actually make sure that that is happening the way that I want? And I think that we could even structure this from sort of the bottom up, right? So we started with screen, and I'm just running screen, and now I've got a process, and it's executing.
Even screen is one level too far from. I literally run the process, and it's there, and I'm
just SSH'd in,
and I'm watching it, and I'm watching it. And I'll control C it, which is also valid, but it gives us a sort of starting point of like what happens when you fire up a process, and why is that not okay?
Yeah, right. Yeah, that's great. I love this. Okay, so it's like, when you do that, you're like, all right, my plan for deployment now is I'm going to SSH onto the production server or EC2 instance or whatever you got, and I'm going to copy and SCP my bits up there.
Yeah, let's not get into packaging and deployment. That's even more complicated. Let's leave it at that. Some magical process happens, and you have the bits that you need on that machine.
Yes,
and then
I have my executable bits on the machine, and then I'm just going to run it. Well, now what you have is you have a process who's a child of an SSHD process.
Probably a child of the shell that you ran it on.
Oh yeah, no,
depending on how you do it.
I
mean, if you're
looking at you're absolutely right. So if you got the tree, it's like, okay, it's a child of bash, and then bash is going to be a child of SSHD, and then that's going to be a child of the parent SSH server, and then that's probably going to be a child of a init, right? Like roughly,
which nowadays is probably system D. Yeah. Thorin, son of Thrain, son of Thror. It's going to be your program. Son of bash, son of SSHD child process, son of SSHD parent process.
Right. So
got it. Yes, that makes sense. All right.
So if you naively, or maybe like not naively, but you just sort of like just have enough knowledge to be dangerous, you're like, oh, I've got the ampersand operator in bash.
Yeah.
That I could put at the end of that, because it's like, okay, cool, the production server is running on my laptop, and if I put my laptop to sleep, or the SSH session, the client is on my laptop, the server is the server, but it's like, all right, I started on the server, now I want to go home, I need to close my laptop lid, and I need to leave. Well, what exactly is going to happen if I close this lid? Like, I don't want it to stop, right? So you're like, okay,
well let's talk about what happens in that situation, just to be absolutely clear. Go. Right, so let me read this back to you. So you're saying, you're running, as described, the production binary having SSH'd into a machine, and you've closed your laptop lid. All right, so assuming you just close your laptop lid and nothing shut down nicely, it just literally suspended. I don't actually know exactly what your laptop will do in this situation, but let's just assume it disappears off the network instantaneously, which is also completely reasonable if you go into like a tunnel on the train on the way home, that kind of thing, right? Then eventually the TCP connection between your computer and the SSH daemon on the remote end will time out. There'll be a keep alive that's missing probably, or some other heartbeating mechanism will go down, and the SSH daemon will say, hey, that person's gone now, it's time to clean up their session. It will, I think, kill the bash process, and the bash process then will kill all of the children that it knows about, something like that. Or there's some sig. Yeah, so this is kind of it, right? So what
signals and processes, right?
Yeah. I mean, I know that the result will be my program will die. Exactly how that dies, I'm not 100% sure, but that's what would happen eventually. Maybe 5 or 6 minutes later, when the SSH daemon times out your connection and says this person's not there anymore, it kills the process tree through some mechanism, and then you get a phone call on as you've got onto the train,
right,
telling you that the production system is down. Please fix it.
Exactly right.
Okay,
and so this is maybe where we troll our listener into posting the right answer on the internet to this, because I would suspect what probably happens is that the SSH daemon kills like the process group.
Of course, because bash becomes a process group controller, or whatever the name is, a leader, process group leader. That's right. There's Where's my Stevens book? I haven't got it here. No, but there's. Okay,
but it's probably going to send a sig term to that process group, and so every process in the process group is going to receive that term signal, and then hopefully gracefully shut down. I don't know if it follows it up with like a sig kill at some point or not. Maybe it does, maybe it doesn't. I'm not exactly sure what a SSHD would do there.
No, but that would seem reasonable, so that you don't end up with loads of processes that just decided not to kill themselves. And frankly, I think bash will probably do the right thing. for that in that process, that circumstance.
So day one, we try to deploy like this. We close our laptop lid, we go home, we get the unfortunate call, and then we rush home, and then we open the laptop lid back up, and then we rerun the process. All right, well, I can't do that. So an enterprising person might say, okay, what I'm going to do is I'm going to use the bash ampersand command because I know that will put a process into the background, right?
Right.
And so I'm going to do that next time. I'm going to do my deploy. I'm going to put an ampersand on the end, right? And then I'm gonna like, and now it's running in the background, and now I shouldn't have to worry about this.
Although, if I were to do that with like a process like we were just talking about, the very first thing I would notice is that my shell prompt comes back, and then immediately loads of junk from my log file is now appearing over top of what I'm running. So even before we get into processes and threads, there's like a pragmatic thing. So what I would probably do is redirect output to, /tilde log.txt. And then put the ampersand on the end. So that I already right. So good. And now it's in the background, and I think we're great. And I'm tailing that log file for a bit, and that's safe because that's a separate process.
Yep.
And now I close the laptop lid and get on the train, whatever, any form mode of. What happens now?
Right. Well, I think what happens, and I think this because I've had this burn me from time to time, is that yes, you redirected standard out, but you did not redirect standard error. And so there is actually still, the daemon has a file handle that it thinks it needs to be writing to back to your thing. And so you put this in the background and you do this again, and it breaks again. It does exactly the same thing all over again.
Well, I think there's more than one reason. So yes, first of all, standard error isn't going anywhere useful.
Right.
The second thing here is that although it is in the background, it's still a child of bash. So it's got you coming both ways. And maybe thirdful, is its standard input is still potentially connected to the console, the terminal, something. I'm waving my hands a lot here because I'm less sure about it. But I certainly know that if you try and read from the console, you'll get one of the even more esoteric signals about like, hey, you're not connected to it right now, and then you'll get stopped, and so you'll see in bash stopped input required or something weird like that. So all of those would defeat you, and you end up with a dead process.
Right. So this is where you start investigating all of the various options that you can pass to SSH when you run this, because you're like, all right, I'm going to make a script. I'm going to make a script that works. And I'm just going to run the script, and it's going to do my deploy, and then I'm going to trust that it works. And you start learning about, okay, well, I need to do the option that like doesn't read from standard in because I don't want the standard in problem. And then I got to make sure that I redirect standard out and standard error.
You're saying this right?
This thing in the background.
Just to be clear, these are options you say to SSH or to the bash?
SSH.
Oh, right? I see. So now we're not going to run bash at all. We're just going to run the executable directly. And
so you're going to run. So I'm thinking of the world where it's like you do a thing, you like copy the bits up to the machine, and then you have like a separate SSH call where you're passing the command that you want to run as an argument into SSH.
Right. So you're no longer running an interactive session. You're just going to, that makes sense. Okay. Then that takes bash out of the equation, which helps us a bit in this context. Although there is still another Bashian solution that I think I see people go for, which is you type disown in bash, which says push this thing and make it not a child of this process anymore. And that probably might solve the problem most of the time.
Yes.
Except you've left a big like rake in the grass for that, because there are other processes on the system that might wish to get rid of that apparently now orphaned process. So that's what no hups are for. It's like it gets rid of the hang up, and there's some other things that it does, and then there's demonization and other bits and pieces, which I'm sure we'll get to in a second. Okay. But let's put that to one side and let's go down the rabbit hole that you've described, which is that like I'm now going to run SSH on my computer, and I'm going to pass it rather than just SSH. I'm going to do /path/ to my executable with all the redirects and things set, and try and run it from a server and have it live on the remote machine with all of the pipes and things, stood input, stood error, and stood out, all connected to sensible places. So
yes,
go ahead. Sorry, that's where I cut you off.
So you do that. And then you should, I believe, be able to SSH in separately and do like a PS tree and see that the parent process of this. The parent of this process is now 1 because it is disconnected from what it was doing before, from the process group that was in before. And at that point, you maybe have something where you can close your laptop and have it hang out. Now, hopefully you sent your logs somewhere sensible and you don't fill up the disk with logs. You can pipe it into syslog, which is something that I do when I'm trying to punt on this problem entirely. I'm just like, you know what? There's already a log rotation system on this machine, and it's called syslog. So I'm just going to pipe all my logs into that.
Quite possibly you already have log aggregation set up for that so that you can go and read it on like a website and all that kind of nonsense as well. Maybe. I mean, but yeah, if you're considering that option, you probably don't, because you probably don't have any other infrastructure to lean on.
Right.
Yeah. Yeah. Okay. So that seems reasonable.
Yeah. So what do you do? What do you do after this? So you do this, you finally can go home now. You can shut your laptop and go home. And you're like, all right, surely we can make this better than this. What do we do next?
Yeah, right. I still have.
You make the systemd job is one is.
Well, see, I was thinking another thing that there is a process called. Process is a terribly overloaded term. There is a sequence of things you can do on a POSIX system to become a daemon.
Mm-hmm.
Not
incantation. You got to sacrifice something. And
that's correct. Yes, there's a pentagram involved.
Yeah.
And not a daemon also, because Matt Damon is the only daemon. So aside here, so as you recall, one of the first folks at the company you still work at was also called Matt and was not me. Yeah. And we were discussing various long-lived processes that we were designing a system to use. And the obvious name was the Matt Daemon. To be pronounced Matt Damon, obviously.
Right.
But we never did it. Anyway, demonization is let's not get into politics. Becoming a daemon, as I understand it, is a multi-step process. The first thing you need to do is fork, which gives you a new process, a shiny new process. Mm-hmm. Then you call something called set SID, which says, I would like to become the session leader for this new process that I've been created, because only a process group, and I'm doing this from memory, so listener, please. And although Ben's nodding, this is not necessarily correct. So just take this massive pile.
You may be hallucinating all of this.
We are. Yeah, let's not. Yes. So you fork. The child process then does set SID to become a process leader in a new group. And then if I remember rightly, you have to fork again to then dissociate yourself from any last tendrils that previous process had. And now you're running and you are completely in the clear. It's something like that. It's some weird sequence of events, which means that you have lost all connection with the previous process. And so when you run some like system process and you pass it with -d or -d, sorry, then and it immediately returns and disappears, apparently like, hey, did it do anything? But you run PS and it's still running. That's the kind of process that it's been through. And you can type jobs and it won't be there. It's like completely lost from you. And probably I don't realize that the thing you were just talking about, and I'm having the penny is dropping now, some of the flags that you were talking about finding for SSH to set it up correctly might be the ones that effectively have the same side effect. But having just written something that is a daemon for if you go back to the systemd conversation we were having last time, something became a daemon and I went through that process. So it's a bit somewhat in top of mind. And even though I had a demonization thing there, I still, you can choose, I think, systemd, which we're going to say either systemd runs the process and does that for it in its own container, or it's expecting it to run in that particular way. And so it can babysit different types of processes, if I remember rightly. Okay. Let's go back to what you said about systemd, because that sounds like a useful thing to know about.
Right.
What is
systemd? So just to put the problem in context, systemd is a solution to a problem. What's the problem? Well, so here's the problem. So you've written your script.
See the last conversation we had about it as to what solution it might be, what problem it is.
What problem are we creating by solving another problem? Right.
Yeah.
I think actually is that a thing? I feel like I've said this before on the podcast. I don't remember. The difference between computer science and software engineering. Do we know this one? Computer science is solving problems with computers. Software engineering is solving the problems that you create when solving problems with computers. And this
Yes,
is
follows.
exactly
That checks out. The math checks out for that for
yeah.
certain.
And so, what problems are we both solving and creating by using systemd? Well, so you write your bash script, it deploys your thing, you shut your laptop, and then you wait 5 minutes, you open it back up, and then you SSH check and it's still running, and you're like, all right, I think I maybe believe that this is going to work, and you go home, and the next day you come in and it's still running, cool, and then 3 days later it crashes, and you're like, you know what would have been super cool is instead of me getting a phone call in the middle of the night because it crashed, if it had just restarted.
Well, I mean, wouldn't it be cool if it hadn't crashed? Would be what the first thought you'd have.
True.
But at 3 a.m, you probably just want to go, oh, for God's sake, just restart the thing.
Just restart it, please. I'll fix it tomorrow, but can we please not call me because I have to SSH back in and rerun the script again or whatever.
Right.
So you're like, I want this to restart. And then you Google and you're like, well, maybe I should run this in systemd, right? And so you wind up making a whole systemd job definition, and I forget where do you put it? You put it in Etsy something, right?
Or is it? Yeah. So
I don't even remember now.
So I mean, my understanding is in the beginning there was init, and init is effectively the first thing that the kernel executes as a user process, and it then decides what to do. And back in the mysteries of time, there were like run levels, and it was all like clever directory structures and things like that, and it just fired up the right sequence of daemon processes, one of which would be a SSHD, so you could log into the machine, or a getty that would let you type on the console to get into the machine, and that was it. And then after that, you're off to the races. And systemd is the new init, and instead of it being a set of essentially shell scripts that get run to fire things up in the right order. Again, I'm probably a bit missing loads of bits of context here, but it's a sort of a more principled approach where you have units that are like, I would like this thing to run, please. I would like this to be true under these circumstances. And it depends on these other things that also need to be either running or at least have started before me. And so instead of having essentially numbered directories with 40 dot do this
rc.d or rc.1 rc.2 something like that.
Those were the run levels, I think, which was slightly different because it's single user mode versus multi-user mode. But this is more like, hey, what sequence do I need to run things in and shut them down in order for my system to come up? And systemd does that kind of the right way by actually tracking dependencies, which again was expensive and caused me problems in our last conversation, but is the right approach and the correct thing to do. And so that's what systemd is. It's like the overarching orchestrator of a computer and all of the processes that are running on it. And so, yes, to make something run in systemd, you put a file in the right magical place, you issue the correct incantation to systemd to go and notice that file is there. And then what?
And then
I'm looking at you because I thought you might have just done this and you could answer the question.
You need to reload the systemd.
Yeah, there's like daemon control reload or something. That's the magical incantation that says, hey, systemd, look through your configuration files. Something has changed.
Yes.
Please do the needful now.
And then it should start up. And then you're using something like journalctl to look at the logs of the thing to make sure that it started.
Is, I think, for most people, when Linux systems particularly moved from init to systemd, the biggest frying pan to the side of the head was, where are all my chuffing logs? They used to be in varlog whatever, and that's burnt into my mind. They are text files and they're in varlog blah, and systemd stopped that. And now there are a few logs in varlog, but nowadays you have to interact with it through, and it has a binary log file format, as I understand it, behind the hood. And you have to learn journal control, journalctl, which I still haven't learned. And I still Google the same thing over and over and over again and type in the thing that it tells me to do, which is note to self. Don't do taking a note here. Don't do that. Make a cheat sheet for it. Stick it to my monitor like all the other cheat sheets I have. Yeah. So that was like that broke most people, I think, because I didn't have to interact with adding and removing daemons from my system. That's what my package management system did. But whenever something went wrong, I'm like, where the hell's the log file?
Right.
Anyway, so
It's in
journal
this
control.
magical program called Journal Control. Okay. I feel like this
So,
is like I want to go to the next level now. It's like, okay, cool. We're gonna run this on like 2 computers because we
well, let's
discovered that the
finish the
reason it
thought.
crashed is it got
So just to
killed.
be right. Let's just finish the thought there. So
Yeah.
very concretely,
Yeah.
you would install the binary to a known good location, which you
Mm-hmm.
probably were anyway. It wasn't just
Yeah.
your home directory, hopefully.
Yeah. Pick a
Maybe it
user that
was.
you're gonna run it as.
Yes, that's true.
Might be root, might not.
Yeah, let's hope it avoids being root if it can.
Yeah.
But then, yeah, you make a little text file that sort of it looks like toml-ish to me, that
Yeah.
systemd-config-ish
Yeah.
file that says, "Hey, I need these things. I provide these things," which you often don't have to
Mm-hmm.
do. This is how I'm going to be started up.
Yeah.
This script needs to run before I run. This script needs to run after I run. There's a few like customization points you've got like that, and you can say what you're wanted by as well. So in this instance, you probably say, I'm wanted by multi-user.target, which is like a magical sort of target that says, hey, when it becomes a multi-user system, the 5th, whatever, run level 5, then this is, I am saying that I am wanted by it, which is a way of you kind of going the other way around from the usual dependency, saying it depends on me.
Right. You're joining
That
the
means,
dependency tree there. Yeah.
yeah. So now when you reboot the machine, your service will come back up. And then you can have some policies about retrying, restarting it,
Mm-hmm.
maximum number of times to restart, how long to wait between them, those kinds of things. And then effectively it runs itself after that. So that's what we do. Yeah.
Yeah.
And so your installation process is copy the binary bits up and make sure that this systemd configuration is there. And then obviously if you want to restart it, there are processes for restarting its service, restart, and all that kind of good stuff.
Yeah. Service CTL.
Yeah, is that what you use? I'm still use service space, service name restart. There's almost certainly 100 ways to do it. Honestly, I still want to go var run blah or whatever the whole old thing was. I actually don't know what the command is, but it just comes out of my fingers when I need to say make that thing run again. But yeah, service space name of thing space restart is now what I've learned to do. But okay.
Okay.
So that's where we are. Right. Okay.
Yes.
So now we're good, right? We know that the process is being appropriately managed by a piece of software that's designed to start it up at the right time and keep it running. It also has some handling for like if it does output to standard out, it'll go to a well-defined log place inside this journal control thing. If it crashes, it'll restart it. If you reboot the machine, it'll come back up with it if you set that to be so. Everything is wonderful. So what's next?
Right. So what's next is that you discover that the thing just crashes every 4 or 5 days because it's running out of memory because it needs to run on more than one computer. It is too big. So you have to now run it on multiple computers and you have to distribute whatever work it's doing.
You've ruled out there's a memory leak type issue.
It's not a memory leak. It's just too much data.
Yeah. Too much. Yeah.
Yeah.
So what do we do now then?
So now we need to run it on multiple computers. And so like one thing you might reach for here is Ansible.
I was going to say is probably duplicating the line in the SCP space SSH machine service blah restart and just do 4 host
in host list. Yes. And just do
so
the
that's
exact
the first
same thing. Yes.
I would do, right? At least to start with, right? That's the V0 of anything. Is like, well, okay, let's deploy it to the 2 computers I know about right now and just do the same thing on both of them. And then
that is probably what I would do. And then I would have the thing where I would try to deploy it and there'd be some package or some configuration. Oh, we got to increase the size of the maximum size of the receive buffers on the network. And so now I've got to like go and change that configuration. I got to change it. And I've already scaled this out to like 10 computers now. Like every month for the last, 10 months, I've been adding another
host to the list of hosts.
List of hosts. Now it takes like, 3 minutes just to iterate through all of them. And I'm like, oh, and I have to remember to log in and set all these settings every time I add a new host, and it's getting worse and worse and worse.
Okay, so we've now gone firmly outside of signals and processes, and now this is like the setting up of the machine here is what you're talking about, which is valid. And if you think of, the system, the systemd configuration unit file, whatever we just said, as being part of this machine configuration, then it does make sense to talk about some of the other things that you might need that machine to have set up, like packages and, as you say, system settings. So let's segue into that. Let's do it.
Yeah. Okay. So you've decided that now, okay, I need to retire this bash script. It's served me well, but it's time to move on to something a little bit where I don't have to like build all this stuff myself and make sure that it works and troubleshoot it all. So I'm going to try to use Ansible. Let's just say.
And what is
Um,
Ansible, and what makes something able to be antsed, which is presumably what
Ants.
it means?
Well, first you have to have pants, and you can have ants in your
That would be
pants, and
pantsable.
then Pantsable. That's going to be the fork of Ansible. Is
Okay.
Ansible. Um, so Ansible is honestly a tool that I have only used sometimes. It is not. I sort of like wind up making the jump from like uh, the shell script to like Terraform. That's usually what I do. Is I'm like, all right, I'm gonna go and I'm gonna have something like Nomad manage these, or I'm gonna manage them in the
I
cloud.
see.
I'm
So
gonna start making Docker
at that
containers.
point, you jump straight out into sort of an orchestration environment as opposed to
Yeah,
I'm controlling individual machines. Because that's the other thing in here, that host list and the
yeah,
provisioning
yeah,
of those machines. We're assuming that these machines exist and you haven't got to like
yeah.
make them appear in EC2. So, but let's
Yes,
go through what Ansible is,
but
because I
real
think that
high
is interesting.
level, Ansible is you write a playbook, and I think that playbook is pretty much in YAML, and it's got like the steps that you want to perform, and there's like a lot of sort of baked in things of like, oh, I need to copy this artifact from this place to this place. Cool. I need to create a configuration file here. Cool. I need to restart system D. Cool. It can do all those things for you. And there's lots of baked in tools in Ansible to sort of do the typical system management things. You can install packages, you can create users, you can, because it's like, hopefully, like you said, we weren't running this thing as root, so we had a dedicated user for it. When I'm setting up a new machine, I need to make that user. I need to make sure they don't have a password, that they have the right SSH keys, all those kinds of wonderful things. So you have some, script or some playbook that you run as root, because it needs to be able to do all these things, but then it sort of sets up the environment, and then like subsequent deploys and things can, kind of, the program can run as a user, and it doesn't need to
Got it.
as root.
Right. That makes sense. So it is essentially a that word
Mm-hmm.
of the steps that you need to do the playbook. I mean, that's a good name for it,
Yeah.
right? Like
Yeah.
it replaces the playbook, which is the Google Doc that you have that says,
Mm-hmm.
when you create a new machine, here's the 25 steps that you have to do, and you kind of roll your eyes and do them. And it's like, well, let's automate this, and it
Yeah.
does it in a principled way using with a bunch of support files that help you uh, make support functionality that lets you do like add user rather than having
Mm-hmm.
to go whatever steps that you actually have to take to add a user, which I forget these days. Okay, that makes sense to me.
Mm-hmm.
I think one of the things that I have had difficulty in getting my head around when looking at these sets of tools, and only because you've mentioned Terraform, one thing I like about something like Terraform is that you kind of describe the end state,
Yeah.
and Terraform's responsible for getting whatever the current state is to the end state.
Yeah. Yeah.
So, whereas with things like Ansible, as I understand it,
Mm-hmm.
is you have to be very careful to either be idempotent, so you can run the same thing twice and it doesn't re-add another user if there is one
Mm-hmm.
already called that thing, um, or you just have to don't run that step again. Like, hey, once we add that user, don't try and do it again. And then you kind of
Yeah.
go like, well, now I want to change the user to have a different, full name or a different shell or whatever. And you're like, now I have to run the change command, and
Right.
I can't just change the add. And Unix systems are so complicated. I can't actually imagine how you could write a general purpose, like make my system look this way thing, except for at least one listener, somebody is currently shouting Nix into the void as they're walking along. And I know that Nix solves this in a very cool way, and I'm very excited by it.
Yeah.
But I don't have any personal experience with it other than someone demoing to me and me going, wow, that is super cool.
Yeah.
But
I've
so
heard those same
just
things about
for
Nix, but
that,
I
yeah,
didn't
Nix
know
seems to
personal
be,
experience.
it seems to be like a kind of a mind virus that people get, not in a bad way necessarily. That does sound
Right.
pejorative, but like, because once you get it, I think you're like, oh my gosh, this is how everything should always be done,
Yeah.
and that's
Yeah.
great. And you become like proselytize it to everybody,
Mm-hmm.
and then most people's eyes glaze over. And
Right.
you're like, that seems great. And then you just log back onto the machine and just go sudo apt install Bob, and you're like, there we are, we're done. Anyway, back to oops, I've just banged my. Sorry, editing Matt. I've just whacked the microphone stand. So
Hmm.
where were we? So I was sort of saying that there's this sort of difference between sort of prescriptive run these things in order, and maybe they're idempotent, or maybe they can adapt and say like, well, if there's a user already there, don't re-add it, that kind of feeling, versus the Terraform thing where you just say, I should like this to be the end state. Here is a list of users the machine has to have with the properties that users have.
Right.
And then Terraform goes behind the scenes and goes, well, why don't I look at what users I've got? Oh, now I'll make a plan. A plan is add 3 users, delete 1 user, and presents it to you and says, this is what I'm going to do.
Yeah. Have you ever actually used Terraform to do that type of system administration before?
Not on a system, no. I've only ever done it with infrastructural
Right.
components.
Yeah.
So yes, that is true. I've never used it
That'd be
for.
amazing. I don't know if it can do that, actually.
I don't
It'd be
know that it
amazing
does.
if
You're
it could
right.
do
Yeah,
that.
now I say, but certainly that's where I was going with that. It was less that Terraform specifically, but like the
Yeah.
phrasing is either outcome or steps, and it's nice to supply the outcome. But yeah, I don't know if something does exist. And my only interaction with things like that are with Packer, where I always start from a script, an empty image, and then run the
Mm.
sequence of steps to make an image that looks the way I want it to. So I never go back to it and kind of go, hey, I want that image, but slightly different. So
Yeah.
yeah, anyway,
Yeah. But
we're
yeah, maybe
all over
that's
the place.
I feel like this podcast is like the rough draft of a conference talk, because it's like, imagine that you want to run a program. What do you do? And you just sort of work up from the bottom up, and then
I
I
think
feel
that's
like
when
could be
was
a
the
good
last
talk,
time
right?
you gave a conference talk? Come on, it's your turn.
Oh, it's been a long time.
Because
I'm probably overdue, honestly.
very much part of the last week's conversation, the reason I was looking into that was because I was avoiding writing several conference talks that I have to give
Mm-hmm.
in about a month's time.
Mm-hmm.
And a week has passed since we last spoke. Oh, now I'm giving away all of our secrets. Uh, although much longer will have passed in real time, and I've probably given the conference talk by the time I've released this. So, listener, you can be the judge of whether it was any good or not. But yeah, I have done no work on it at all. So, oops.
Mm.
But yeah, this is a rough draft of a conference talk on.
It is.
So you want to deploy a service, or so you want to
Yeah,
run a service?
exactly.
Yeah,
So you want
yeah.
to run some software, right? How are you going to do it? And I feel like the punchline of this is like, okay, and now we're migrating this all to the cloud, and we're going to use Terraform, we're going to use GCP, or maybe you have like, a lot of companies I feel like these days have like essentially like an internal cloud. Like they're still using
Mm-hmm.
Terraform, but they're using tools like Nomad, and they have their own, physical servers, and they have an infrastructure team that's managing it all. And this maybe leads us back. This is how you get this. Okay, this is the whole punchline. This is how you get into the state where you're just like, yeah, I just like changed one function with some unit tests and pushed a PR, and I have no idea where it goes.
Yeah, that's exactly right. Yeah.
Yeah. Yeah.
Well,
And now the circle is complete.
and now the circle is complete. Yeah, I think
Yeah.
we've probably reached a good spot then. Yeah.
Man.
It's good to know these. I think like all of these, like everything we talk about, really, certainly everything that I hold dear that we talk about on this podcast is all about finding the right level of abstraction, knowing
Mhm.
that there's a level beneath you, which in this case, maybe your level of abstraction is those cloud tools that we've just been talking about and the services to run, but knowing enough about the level beneath you to say like, okay, I do know that there are processes that run and that something is taking care of the input and output for those processes and making sure the right signals get to them at the right time and not the wrong things like me logging out. But
Yeah.
I know that they exist, and maybe I could sketch something, but I don't necessarily know off the top of my head. And then you should know beneath that that something exists, right? Beneath that
Yeah.
layer, we know that there is a system D, and I don't know how that works, but
Yeah.
it's always good to have a decent understanding of the level beneath where you're working and then be aware of the layer below that.
Right. Know vaguely what to Google. Or
Right.
ask ChatGPT, right?
Or
Yeah.
ask your
Yeah.
favorite,
Ask your
large.
favorite LLM. Yeah.
Yeah. And so I think
Yeah.
this plugs into that kind of mindset completely. It's like,
Yeah.
it's kind of like know how the cloud works and then know where to look when it doesn't work.
Mm-hmm. Mm-hmm. Yeah. Like
Cool.
if you honestly, the only downside to this is that in those environments, I feel like where you have those like a million layers of abstraction between you and the physical server, if you're like an old fuddy-duddy like us, and you're like, can't I just SSH in? It's like, no, you can't have root. It's like, why? I know exactly what to do. I know exactly how to fix this problem, and now I'm going to have, okay, fine, sure.
Yeah. Well, and of course, the irony is they could probably give you root, but it's not even on the real computer because you're several layers of virtualization away from the machine that's actually running. You talk about
it's like it's running in a container service. There's no root to give you. Like you can't get there from here, right?
Yeah.
Yeah.
Cool. All right, friend. Well, this has been great. We jammed it. We did it.
Not bad for winging it.
Yeah, listener, you can let us know. Post a comment somewhere. I mean, some people watch this on YouTube, and that's where I see most of the comments. And then otherwise, tweeted us or hackyderm.io Mastodon-y thing, or just email us. You can get us. But we'd love to hear what you think and what we're doing right and wrong. We never really asked that. We just do this for us. This is just our excuse to catch up, isn't it?
Yeah, that's true.
Cool. All right, friend. Well, have yourself a great weekend, and I'll speak to you soon.
Until next time.
You've been listening to Two's Complement, a programming podcast by Ben Rady and Matt Godbolt. Find the show transcript and notes at www.twoscomplement.org. Contact us on Mastodon. We are at twoscomplement@hackyderm.io. Our theme music is by Inverse Phase. Find out more at inversephase.com.